When you talk about the definition. So definition are too simple. Dot product of two vector result in a scalar, and its calculate is the sum of product of their corresponding component, right? Okay, I hope dot product of a two vector result in a scalar, and it's calculate the sum of product, right? Sum of product of their corresponding element, right? What it said corresponding element? What it mean all? In today's video, you understand, okay? First, let's get the example. Okay, now we are going with the first element vector is a 2 and 3. This and second vector 4 and 5. We simply get a dot product of A and B, right? So in that case, what we will do? We simply create a dot B. A dot B is a what it's a corresponding component. Right? Corresponding component means 2 multiplied by 4, and similarly 3 multiplied by 5, and this is sum of the product, right? Corresponding component and sum of their product. That's a simple concept. So in that particular case, you simply get 2 into 4 plus 3 into 5. Okay, so we get 8 plus that's 8 plus 15 is nothing but 23. This is your scalar value, right? The dot product two vector result in a scalar value, right? So this we get a scalar. Similarly, okay. So what we will do? We simply get a transpose of B. Okay. So B transpose is nothing but 4 and 5. Okay. So 4 and 5. After that, we calculating A dot transpose of B. Simply we get a 2 multiplied by 2 multiplied by 4 plus 5 multiplied by 3. 8 plus 15. So simple same we get a same answer. Okay, 23. It's a dot product of two vector. We going with a representation. Okay, we understand the how mathematical representation you perform. So simply first of all, okay, simply you first draw representation. Okay, and simply we draw one, two, three, four, 5, 6, 7, right? Similarly, 1, 2, 3, 4, 5, 6, 7, -1, -2, -3, -4, -5, -6, -1, -2, and something like that, right? Okay. So we simply get a vector A. A vector is a 5 and 0. Okay. And similarly, vector B is nothing but 2 comma 2. Okay. So this is a we have two vector. When you draw a line, so this is a 5 0. It means that line is a something like that. Okay. So this point is nothing but 5 comma 0. Similarly, when draw 2.2, so 2.2 is somewhere here. Okay. 2 comma 2. Okay. So when we draw a line, okay, so how we get a length? So we understanding the representation using the graphs. So first, we simply draw a line, okay, and this is a line length of line, and simply be perpendicular to that line, okay. Basically this is a second line, okay, perpendicular to that line, and simply we calculate the length of vector B, okay, length of basically this is the length of projected vector projected projected vector, right? length of projected vector. Similarly, when you calculate the dot product of both, okay. So A dot B is nothing but length of length of project B project B uh, multiplied by length of vector A. Okay, length of vector A. So this we get. So what is the length of project B? Is a 2, right? 2, and dot product with the length of vector A is a 5. So we simply get a while value 10. This is the dot basically length of projected B, okay, and length of vector A. This is when you multiply the both of things, you get a same result. So okay, that's all okay. You understand about the dot product. But we are learning in a machine learning data science, so we understand some real world application of a data science in a particular video. So we are going with a okay real world application of dot product. Okay, real world application of dot product. So real world application is the most commonly useful, that is cosine similarity. Cosine cosine similarity. It's the most useful thing that you will see that you will see because when you when you learn the concept it's like a NLP, NLP, right? That's very useful. And basically, that's the mostly used. Okay, so understand it's the use in a recommendation system, right? In a Netflix, YouTube, Instagram, all social media platform give a recommendation. So how they can give a recommendation that will be determined determined using the cosine similarity, right? Basically, cosine similarity it's a okay, it's a range between -1, it's mean a dissimilar to +1, which means similar value. Similar value. This is the range we will cosine range, right? Second one we are going with the formula. Okay, so formula is simple. Cos theta is equal to dot product of A and B and magnitude of A and magnitude of B. This is the formula for a cosine theta. Okay. We are this is used for a recommendation. First, that's we have one movie and that's a rating something. Okay. One movie is let's Avengers. Okay, that's we have a movie, and there's some drama, action, all this something pointer between the two uh, 0.5, 0.3, and 0.2. Okay, and another movie is a point something like 0.2, 2, okay, 0.3, 5.9, sorry, 0.9, and let's 3. That's we have point, okay. So using first we get a dot product of both of this and then magnitude and calculate them, right? So is a ranging between the g minus 1 to 1 that decided how similar that movie from the Avengers movie, right? And then decided their actual after watching your Avengers movie, they actually decided the movie, basically the second movie, recommend you or not, right? This is our cosine similarity, right? And this is used in a dot product. So, okay, for today's video, and another multiplication we understand in the next video.